Hello everybody. In this video we're going to start talking about the bonds, and the first type of bonds that we are going to discuss is the ionic bond. And the ionic bond is formed between metals and nonmetals. So we are talking about the first one or two columns in the periodic table and column 6 and 7a before the noble gases. And these metals have low, so the metal should have a low ionization potential. So, which means that it can easily get rid of the outermost electron and convert into a positive ion. And the nonmetal has high electron affinity, so it can easily convert into a negative ion. So it's like sodium and potassium for metals, and fluorine, chlorine, bromine for the nonmetals. And what happens here is that the metal completely gets rid of the electron, and the non-metal completely or accepts that electron. And this is actually a win-win situation, because this metal is not in a stable state and it needs to get rid of this electron, and this is in an unstable state and it needs to gain this electron to convert into a stable state. And what happens is that the positive and negative ion will get attracted to each other because of the difference in charges, which makes this bond a very, very strong bond. Um, uh, and the distance between the atoms is like a topic that has been studied by many scientists. And just to talk quickly about it, the ionic bond length is dependent on two factors. The first is the attraction force between the sodium and the chlorine ions, or the positive and negative ions. And this is calculated from this equation, which is the attraction force function of the charges and the distance between them, the permittivity of space. And when they get closer to each other, the electrons start to or a repulsion force starts to form between the electrons in the two ions. And therefore, the repulsion force can be calculated from Born equation, and from this like these two equations, we can calculate the energy, or before the energy, we can equate them, so we can calculate the value of B, which is function of the distance between the two ions. Anyways, so we can calculate the total energy for an ionic bond by calculating the energy of attraction between the two ions and the energy of repulsion between the two ions. And in case of equilibrium, or the actual bond length would be in the case of the minimum bond energy, which is this equation is it's by making these two equations equal to each other. Um, Anyways, to make the long story short, this is the equation that describes the or what we call the bond equation, the Born equation. And this Born equation is a function of the distance between the two electrons, and the n, which is a parameter that ranges from 5 to 12. What I'm interested in is to get the physical meaning of this equation instead of going into the details of the equations. The physical meaning is that we know when the electrons, or the two ions, are far from each other, there is no repulsion force because the electrons are very far from each other, but the ions can feel that there is a difference in charge. And that's why the attraction force is weak, and as we get closer, the attraction force gets stronger. So this is kind of high energy in the attraction direction. So this is the attraction force, which goes down. And the repulsion force is high as the two atoms are, or the two ions are close to each other. The attraction force is very high, and as they get farther from each other, the repulsion force decreases. So this is the force of repulsion, which is going up, and this is the force of attraction that's going down. And the net force is going to be the difference between the two forces. And if you check the equations, one of them was positive and the other is negative, and this is the positive and this is the negative, and this is the zero line. and the net energy is gonna be this blue line, which is the summation of the two lines. It's gonna be totally dependent on or dominated by the attraction force for big distances, and dominated by the repulsion force for large distance, very small distances. And the net force will be this blue line, and we would expect that the minimum energy would be, or this distance would be the actual bond distance because it has the minimum energy. So this is the equation, or the point in general, or in brief. So for the ionic bond, it's interesting to relate how the bond forms to how the crystals form, or how the molecules look like in the real world. So just think about it like the sodium chloride, which is the table salt. Table salt is kind of crystals, and they are very hard crystals. And the reason they are formed of crystals that are that hard is because of the way the atoms or the ions are arranged. So they are arranged in a closed packed arrangement like the one we see here. The blue are the positive ions and the sodium ions, and the green are the chlorine ions, and they are closely packed so that they are very, very strong. And again, the having ions of different charges makes the attraction force extremely strong, and that's why it's always in a solid state. And it takes the crystal shape because of the way it's arranged like this. And we can never say that, or we can never expect that you can have a sodium chlorine molecule just by itself. It is always part of a packing of molecules that form these crystals. For ionic bonds, we know that they should have, or would expect that they have high melting point and boiling points because of the strong attraction force between the ions. We would expect that it has low electric conductivity, and this is because the charges are stuck in their place. They cannot move. They cannot go from a place to another. But they have high solubility in water because of the charges that they have, so they can ionize easily in solutions. And when they are in solutions, the ions can easily transfer from a place to another, so they can um, be conductive in solutions, but not in, or whenever they are molten, but not in the solid state. We said they have high solubility in water, they have good mechanical properties because of the closed packing, and they have the electroconductivity decreases with temperature. As the temperature increases, their electric conductivity decreases, and this is the relation that relates the resistivity to the resistivity at infinite temperature, at very high temperature, multiplied by the exponential of E divided by RT. Um, so this is for the ionic bond. I'm gonna stop here. In the next video, we are gonna talk about the next bond, which is the covalent bond. So I'll see you then.